Hi, it's Mr. Blystone here. This is the first video of Unit 1 of Geometry, and we're talking about dots as points. So let's look at how dots are used as points in the real world. So, in electronic screens, they're made up of things called pixels. And these pixels are aligned on a matrix or a series of rows and columns. Now, if you look at the image, this is essentially a matrix of pixels making the Monopoly Man. In this case, we're only using black and white, and they're either on or off, so the pixel is either shaded in or not. Altogether, on that matrix, we have the Monopoly Man here. And on color screens, they can be on or off or show a specific color. And the number of pixels across multiplied by the number of pixels down is known as the resolution of the screen. Now, just to kind of give you an idea, if you look at a screen that you're watching this video on right now, even if you hold your eyes right up to it, you couldn't see a single pixel. They're so small. Because we've gotten very high resolution screens. Just to give you an idea, in some of the early days of computing, some of the first color monitors could do a good color resolution of what they called 320. So that's 320 pixels across by 200. 200 pixels down. That's only 64,000 pixels. Compared to a relatively low-resolution monitor today, we wouldn't consider this very high resolution. We have, monitors go up a lot higher, 4K, 8K. If we think about there's 1600 by 800. That's a decent resolution. Let's look at that one. 1600 by 800 is 1,280,000 pixels. Compare that to 64,000 pixels. That's huge. That's absolutely just big. So yeah, compare the two. Pixels have gotten a lot smaller, but we still use them. That's what we still use. Everything on your screen is a single pixel. It's just, and nowadays they're a lot smaller. And on phones, they're tiny, teeny, tiny pixels. So let's look at other things that use dots as points. So, look at this road sign. You've probably seen road signs like this if you've ridden around in a car, or ones that are hanging from poles and things like that use individual lights to make letters or numbers. Those would be pixels, basically. Those would be points. Or a marching band making a picture on the field. This is University of Michigan, making a big M. And each band member is a point of that M. And all together, they're making the M right there. So, when we're talking about dots as points, we're talking about something called discrete geometry. So let's look at a few definitions. So in discrete geometry, a point is just a dot. That's all it is. And a line, therefore, is a set of dots in a row. We think of a line normally as something, or we'd think of it something like this, a line. But in discrete geometry, it's something more closer to this. A bunch of dots in a row. So let's look at types of lines we can have. So we can have a horizontal line. Horizontal line would look like that. We can have a vertical line. I'm going to try and straighten this as best we can. There's a vertical line. And there is an oblique line. Again, in discrete geometry, it's a bunch of points. Doesn't matter if I draw them as circles or squares, it works. All right, so let's look at some ideas of discrete geometry. So when a line is thought of as a dot, lines have some thickness, and between 2 points on a line, there may or may not be other points. There may be more than one line through 2 dots, depending on whether you require that the line go through their centers. And it's possible for two of these lines to cross without having any points in common. So let's look at that like this. So let's draw these as more individual dots so we can kind of see it. Let me make them a little bit chunky so we can kind of see dots. Here we go. So let's take a look at the first one. That said, between 2 points, there may or may not be other points. So a line could be that. That could be a line. And, of course, we could have another point, that. Now, the second one says, there may be more than one line through 2 dots, depending on whether you require that the line go through their centers. So we could have something like and we could have something like that. So the line might have this little bit of that one and that, or it might just be that, or it might go through their centers. It could do it either way. Now, the third one, let's go back. It says it's possible for two of these lines to cross without having any points in common. So we could do this. A line, and then between that, there. No, all right. So those have common points, but I could just say, take away that point there. They cross, but they have no common points. No points that are common between them. Remember, we don't connect the dots in discrete geometry. It's just dots. So it could be something like that. All right, there are no examples for this video. So what I suggest, if you're following along and want to try problems 1 through 16. So that's all for this video. Hope it helped. And as always, keep on learning.